Okay, so in this video we're going to continue on the demand worksheet and we're on question 21. Okay, so it says, using a fully labeled diagram, plot the demand curve from the given linear demand function. So the quantity demanded is 900 minus 25p. Well, the first thing I'm going to say is A equals 900, and what I mean by that is this number here on its own, A. That tells us where the demand curve, the demand function, crosses the quantity axis. So we already know a point. So one of the point is P equals 0, quantity demanded equals 900. There's one point. Now, of course, we can always do this, which is just put in a number for P and then work it out. What I'm going to do is, for a demand function, there's never any harm. So QD equals 900 minus 25p. I'm going to set QD equal to 0. So we'll get 0 equals 900 minus 25p. Bring the minus 25 over, becomes plus 25p equals 900. Then we're going to divide both sides. We're going to write it out again, skip a line. Both sides by the number before the letter we're trying to find, which in this case is P. We're trying to find P, so that means we're dividing both sides by 25. And then I go 900 divided by 25, and that equals 36. So P equals 36. Now, why am I doing this? And I've got to stress this. In order to draw a straight line, and all of these in your IB course will be straight lines, we need 2 points. And now we actually have 2 points. We've got P0 and QD is 900. We've got P36 and QD is 0. So just remember those numbers here as I move on to the demand curve, to drawing the demand curve here. Now, just a few things, right? What we actually have here, we have labeled price and quantity. Now, they're not the neatest, but it'll still work, of course, and demand curve. We need to label all of these. Now, bringing this back to the work that we just did. So P equals 0. So all along here, price is 0, all along the quantity axis. And then we also have QD is 900. So this point here is 0, 900. That's the point there, right? So that's 1 point. So we need a second point. And we've got 36 and a quantity demanded of 0. So quantity demanded of 0 is all along here. 1, 2, 3, 4, 5. Great. So we go up to 30, and then that's 32, 34, and 36. And this is the other point here. Now, in order to draw a straight line, we get out our ruler, and it's usually the best kind of practice to take two lines that are very far apart from each other. Just means it's probably easier to draw, and that's our demand curve there, and we'll label that D1. Okay, and that's pretty much, that's just that answered. All right, so again, to draw, and there's be a few of these, to draw a straight line, all you need is 2 points. To draw an accurate, geometrically accurate straight line, all you need is 2 points. Now, another question that's incredibly similar here. Okay, get me my trusty pen out. Okay, so we've got QD, we need to plot it. QD equals 600 minus 50p. Well, again, don't forget, guys, that the A is the number on its own. That's the A, right? And that tells us where the graph crosses the quantity axis, right? So again, what am I saying? Well, I'm saying, first of all, at a price of 0, people will buy, in inverted commas, because they're getting it for free, but they'll buy 600 units. Okay, and then another thing that we can do is, I always like to do this for the demand function, is we set QD, right, equals 600 minus 50p, and we set QD equal to 0. So what we're finding there, so we found where it crosses the Q axis when we set P equal to 0, which is putting in P 0 for P, and you're left with 600. Now what we're doing is we're finding where it crosses the P axis, which is the one going up and down. So instead of QD, we write 0 equals 600 minus 50p. We bring the minus 50 over, it becomes 50p equals 600. Divide both sides by the number before the letter you're trying to find. Okay, we're trying to find P. The number before that is 50. And I believe it's 12, but 600 divided by 50 equals, and it is 12. So at a price of 12, okay, what we're saying is the quantity demanded is 0. All right, so with that, so the first thing we have to write down is P of 0 and quantity demanded of 600. Okay, well, like always, we have our demand curve and we've labeled it. Sorry, and that's the wrong one. Okay, so we have our demand curve here and we've labeled it. Forgive me while I'm jumbling papers. Okay, so we've labeled it demand curve, all right? We've got our price up here, we've got our quantity down here. Okay, so at a price of 0, 600 is bought, there we go. And at a price of 12, none is bought. And just to be clear, what am I doing? I am finding these here. So one way, particularly for demand, for supply it's slightly different, but for demand you should, I think it's the best way to do it is set the P equal to 0 and solve for Q, which is always going to be that number on its own. That's why I didn't plug anything in. And then set the Q equal to 0 and solve for P, and that's what we've done here. Okay, so I get out my ruler and I join the dots. Now obviously, you know, we want to be as neat as possible, and so therefore we try to keep the dots small. I say that even though I don't really do it, or I have not been doing it in these videos. And you also want to keep the ruler nice and straight, a ruler nice and steady, and there we go. Okay, so no problem there. All right, all we're just doing now is finding a few simple points and then putting them onto a line. In a linear demand function, QD equals A plus BP. Now don't forget, demand functions that obey the law of demand, that B is going to be a minus. What does the A term stand for? Well, what it represents is, and I'll just read it out, it represents the quantity that would be purchased or consumed at a price of 0. It is where the demand function crosses the quantity axis. That's what the A stands for. So straight away, remember that. Understand that. It's also known as autonomous consumption, I think. Autonomous demand. Okay, not autonomous consumption, autonomous demand. And that just means that at a price of 0, that's the amount that people would buy. Now, on to question 24. A little bit more involved, but nothing crazy. So we're going to change the A term in each of these functions, right? So we've got QD1, I know this in the middle, equals 200 minus 50p. QD2 equals 300 minus 50p. And QD3 equals 100 minus 50p. So the question says, what's the difference between the three equations? And the A variable is different. The point where it touches, where the function or the demand curve crosses the quantity axis is different. That's what's different, okay? This means that each of these demand equations cross the quantity axis at different quantities. It is equivalent to a shift of the demand curve, and yes, it is. Now, this might be a little bit of a pain, but we're still going to do it, okay? So, for the first one, it says, draw the three demand curves of the three equations on the one diagram on the following page. Right, absolutely fantastic. So the first one I'm going to look at is QD1. QD1 equals 200 minus 50p. Now, again, if I put 0, that goes to 0, so I'm left with QD. If I put a 0 in for P, excuse me, I should be accurate, that whole thing goes to 0, I'm left with QD equals 200. So at a price of 0, QD equals 200. Okay, no problem there. Now I might have to be a little bit economical with my workings out in this space, but still. And then another one I'm going to set, I'm going to put 0 in for QD, so QD equals 0. So I've got 0 equals 200 minus 50p. I'm going to bring the 50p over, and I get 50p equals 200. Divide both sides by 50. And I get P equals 4. So for the first one, right, I have 2 points. I've got P equals 4, quantity demanded equals 0, and P equals 0, quantity demanded equals 200. So what I'm going to do now is stop trying not to make the same mistake as I consistently make, and put those 2 points on this diagram. So just to be clear again, P 0, 200, that's here. And then I've got a P of 4, and a quantity of 0, and that's there. I'm going to put down and take my time with this, all right? Always take your time with this, because sometimes you may be asked to read off the graph, and you want this to be as accurate as possible. They give you a little bit of leeway, but you don't want to count on it, okay? So that's D1, okay? No problem there. Back to the workings out here now. Okay, so now what we've got is QD2. So I'm not going to waste too much time with this. I've got QD2 equals 300 minus 50p. Now we'll come to this, but that number before p, that's the slope. Okay, so we've got 300 minus 50p. All right, well, at a price equal to 0, quantity demanded equals 300. We know that. We've already talked about why. Now I'm going to set 0 as quantity, 300 minus 50p. Bring the minus 50 over, becomes a plus 300. Divide by 50, divide by 50. P equals 6. So at a price of 6, quantity demanded equals 0. Okay, so I've got a price of 0 and 300, a price of 6, quantity demanded equals 0. So we go over back to our diagram. Okay, hopefully you can remember those. Always try and remember those, guys, if you can, just because it'll make it easy. So we've got P0, 300 is here, and then we've got a price of 6 and a quantity of 0 is here. So again, I take my time, absolutely no stress. Okay, no rush whatsoever, and draw my demand curve. Now, if I have drawn the and D2 there, if I have drawn it well, and I think I've drawn it reasonably well, those of you that are relatively comfortable with maths and angles and stuff like that, you can see that they are parallel. And that's right. And I'm telling you that that's right is because the definition of parallel lines are lines that have the same slope. All of these have the same slope. How do I know? Because the number before P is the slope. That's how I know they have the same slope. Okay? The only thing is, this number is bigger than this, therefore we would know that's an outward shift of the demand curve. Now the last one that we're going to do here, if this number is smaller than this number, which it is, 100 is smaller than 200, we should know that that's an inward shift of the demand curve. Okay, so I've got QD equals 100 minus 50p. So what I've got here is at a price equal to 0, quantity demanded equals 100. That's the number on its own. There's 1 point. And then I'm going to put in 0 for QD, get 100 minus 50p. Bring the minus 50 over, becomes a plus 100. Divide both sides by 50. And forgive me, you can't even see what I'm doing. What's the point of this at all if you can't see it? Divided by 50. Cancel, cancel. Price equals 2. So we got that a price equals to 2, quantity demanded equals 0. Okay, and we know that because we've set the quantity demanded equal to 0. So now we're back onto this diagram here, and we just have to put in our 2 points to draw the one straight line. Now I know we will have drawn 3 by the end, but still. So we've got at a price of 0, we've got quantity demanded equals 100, and at a price of 2, quantity demanded equals 0, which is that point there. Okay, so again we put our ruler down, we take our time, and there we go, and that's D3. Now again, what do we see? These 3 lines, they're all parallel to each other. They have the same slope. That is to be expected, and the reason that is to be expected because the number before P is the exact same. As this A figure gets bigger, that is equivalent to an outward shift of the demand curve. So here we move from 100 was A, then 200, so that's an outward shift from there to there, and then from 200 to 300, so that's an outward shift from D1 to D2 here. Okay, so please, please, please try and keep that in mind, that what has changed, not the number before P, therefore the slope has stayed the same. It is the number that has changed is the A variable, the number on its own, and that means that that has caused a shift. In this case, it's inward from here to here, from D1 to D3, and in this case, it's outward from D1 to D2. Okay, D1 to D2, outward shift, D1 to D3, inward shift. Okay, amazing. 20. Here we go. Now, I might, we'll see how far we get, okay, because how long am I doing? 13 minutes, okay. Right, so when we change the autonomous level of demand, that's what the A stands for, from Q1 to Q2, what happened to the demand curve? The demand curve shifted outwards, okay? There's 6 reasons that may cause this to happen. Well, we know of TOIS, okay? T-O-E-I-S-S, okay? So the first T represents taste and preferences of consumers moved more towards this product, right? That's the first thing. All right, then with the O is other related goods prices. So what are related goods? Well, substitute goods are complementary goods. The price of a substitute good rose, meaning that people bought more of this, hence caused an outward shift in the demand curve, or the price of a complement fell. The complementary good is a good that is used in joint demand, something like petrol and cars. If the price of petrol fell, which it has been falling recently, this is in the time of Corona, well then the price of big cars or cars in general, the cost of driving falls. Now, there are other reasons that people aren't buying more cars, which we'll come to in a second. So TOE, expectations regarding future price. Why would people buy more now? Well, particularly when we're talking about expectations regarding future price, they would buy more now if they felt that the price was expected to rise in the future. Income of consumers rose and the good is a normal good. So TOEI, income for I. Income of consumers rose and the good is a normal good. A normal good is a good that you buy more of as your income rises and less of as your income falls. This S is the size of the market has increased, meaning there are more customers. If there's more customers or more consumers, that means that there's more people to buy the good, and hence the demand for that good also rises. And then the last S is special circumstances. So TOEISS. Remember that these are the 6 reasons that cause a shift in the demand curve. Something unusual happened, causing consumers to buy more of the good, and I always use the example of ice cream on a hot day. The demand for ice cream can rise, should rise, may rise. Don't say definitely will. We always like a bit of wiggle room in economics, but the demand for ice cream should rise on a hot day, as people prefer ice cream like ice cream more than usual in order to cool them down. Okay guys, that's the end of that video, and we'll pick up on question 27 in the next one.